So in this particular video, I wanted to go over the concept of a conditional probability. So let's start off with some definitions and then we'll get into some examples. So the probability of an event occurring, given that another event has already happened, is called a conditional probability, right? So you have what I call inside trader information that something has already happened. Well, what's the probability that a different event occurs given that you already know something has happened? And we use a very specific notation here. So we use the notation, the probability of B, and you'll notice that vertical line there, and then A. So that is read as the probability of B given that A has occurred. So we say this, the probability of B given A. In this scenario, A is the given event. So in this particular way that we write this is that A has already happened. A is a fact. We can't change it. And we also know it's very important that the way that you write your events in there makes a world of difference. We note that the probability of B given A is not the same as the probability of A given B. Very important, okay? Because the probability of B given A says that A has already happened. When you say the probability of A given B, now you're saying B has already happened. So make sure you're very clear on what you mean by what's the given event, what's the event that's already happened. All right, so here we go. For example, consider the following table, which compares the use of cell phones by drivers and whether or not they received a speeding violation. Okay, so this is what we call a contingency table, or sometimes you'll hear it referred to as a two-way table. And just really quickly, I just want to make sure we're able to read this table, right? So the way that you read this is that, let's say I want to know how many cell phone users received a speeding violation. Well, I would go to the cell phone user row, and I go to the violation column. I see that 50 people that were cell phone users received a violation. How many people do not use a cell phone and did not receive a violation? Well, we can see that that's 307. Okay. How many total people did not receive a violation? Or that's 427, okay? How many total people did not use a cell phone? 323. So, and then there's a total of 493 people that were surveyed. So really quickly, that's how you read a two-way, or what we call a contingency table. All right, what is the probability that we randomly select a driver that is not a cell phone user? Okay, when it comes to these probabilities, folks, it's very important. Our number one step is to identify our events. You're going to see that's going to be a common theme throughout the next few lectures. We're going to let A represent a non-cell phone user. Okay? So then what this question is asking, what I like to do is I like to convert this statement. What is the probability that we select a driver that is not a cell phone user? Let's convert that to what I like to call probability notation. So big P represents probability. We're trying to find the probability that we select a member of A, right? A person that's a non-cell user. Well, I know we started off this lecture about conditional probabilities, but notice here there's no condition. There's no condition. So anytime there's no condition, that means we're out of the grand total, in this case, of 493. So our denominator is a total of 493 participants. But out of those 493, how many of them do not use a cell phone? Well, you go to the not cell phone user row. How many total of them? There's 323. So the probability that we select a person that's not a cell phone user is 323 out of 493. Now, if you want to convert that to a decimal, we just take 323 divided by 493 to 3 decimal places. We get a 0.655. So a little over 65% chance that we select a person that is not a cell phone user, which seems really high if this is a modern day survey. Anyways, part B, what is the probability that we select a driver that does not use a cell phone given that they've received a violation? What is the probability that we select a non-cell phone user given that they have received a violation? All right, once again, first step, label your events. Cannot stress it enough. We're going to let event A be a non-cell phone user. So A is non-cell user. And we see here event B is that they received a violation. Okay? And so what we need to calculate here is what's the probability that we select a driver that does not use a cell phone given that they've received a violation. Okay? So this is a conditional probability. And actually, what I'm going to do here, guys, I'm actually going to switch these. So I like to do this. And I apologize for the confusion. I like for A to be my given event, if I can help it. It just makes the notation a little easier. Let's let A be the given event. What's the thing that's already happened? They've received the violation. So let's let A represent the violation, and let's let B represent the non-cell user, because now our notation becomes we're trying to find the probability of B given A. Okay? There's nothing special with what I just did there. You could have kept them as A and B as we had initially, but I just like this notation a little better. All right, here's the cool thing. Whenever we have a conditional probability, we are restricting our sample space. So we are no longer looking at a total of 493 people. What we're saying is that the given event is that they received a violation. So we're only concerned with people that have received a violation. How many total people received a violation? Well, if you go to our table, 66 total people have received a violation. So what this conditional probability is saying is that it's saying I am restricting my focus to only people with violations. I'm only looking right here. Out of those 66 people, how many of them now, right? The numerator is going to be the A. How many of them out of the 66 received a violation? The question becomes, do I use the 50 or do I use the 170? Well, we use the 50 because we're only restricting ourselves to people that have a violation. The 170 talks about people that both had and did not have a violation. So the probability of B given A is 50 out of 66. And what's cool, and I want to be very clear here, this trick only works if we have whole numbers in our table like we have right now. What's really cool is that if you look at B given A, it kind of looks like a fraction, right? Where A is your denominator. Well, what's A? A is violation. That's why 66 went in the bottom, because that's the total number of violators. And then out of just those violators, 50 of them used a cell phone. All right, so I hope that was clear. Sorry about the confusion earlier. So 50 out of 66 there. All right, so remember, we want A to be the given event. All right, here we go, part C. Given that a driver uses a cell phone. So right there, that's my given event. I'm going to let that be A right off the bat. So A equals cell phone user. What's the probability we select a driver that has not received a violation? So event B, we're going to let that represent no violation. Okay. So once again, I'm trying to find what's the probability of B given A. I like to start with the denominator because that's what's restricting me, right? So A is my denominator, it's the cell phone user. How many total cell phone users do we have? 170. So my denominator is going to be 170. Out of the 170, so let's see here. So now our attention is focused on this part of the table right here. Out of the 170, What's event A? No violation. Out of the 170, how many of them did not have a violation? 120. There you go. That is your conditional probability. And lastly, what's the probability we select a driver that has not received a violation? There's no condition here, right? So what we're saying here is that there's really only one event. A is that they did not receive a violation. So this is the probability of A. And we're back to looking at the entire data set, the entire table. And so there's a total of 493 total people. So 493 is our denominator. All right, and out of the 493, how many of them did not receive a violation? Out of everybody. So there's a total of 427 people that did not receive a violation. Okay, so I wanted to mix in a couple of questions there where you have restrictions, a conditional probability, and then some where you do not have a restriction. So I'm hoping that's clear. All right, a few more examples here. So it turns out that there is a mathematical formula to determine conditional probabilities. And we could have used this up before, but I think it's just easier just to pick out the whole numbers from the table. But it turns out that the probability of B given A is equal to the probability of A and B divided by the probability of A. What we have to do is we have to use this formula in situations where we're not given a table, or if we are given a table, the table doesn't have whole numbers and it has percents. Like maybe they already have like the 20% and blah, blah, blah. So in that case, you have to use this formula. So the examples we did before, the shortcut worked, like treating it like a fraction because it was whole numbers in the table. But if you don't have whole numbers in the table, or if you don't have a table at all, you have to use this formula. So let's go through an example of using the formula. Suppose we conducted a survey and found that 56% of college students live on campus. 62% of students have a meal plan from campus, and 42% have both. They live on campus and they have a meal plan. Okay. Suppose we met a student while dining on campus. What is the probability that a student lives on campus? What is the probability that a student lives on, what is the probability that this student lives on campus? Excuse me. So what's going on here is that we met somebody in a dining hall, which means they have the meal plan. We want to know what's the probability that the person lives on campus given that they have a meal plan. So once again, let's write that out in words. What's the probability that they live on campus given that they have a meal plan? Because we met them in the dining hall. They're not just there for giggles. They are there to eat. So they have a meal plan. All right. So once again, I want to use the notation where A is the given event. So we're going to let A be the event that they have a meal plan, and B is that they live on campus. Okay. And then next I'm going to rewrite our formula. So remember we said the probability of B given A is the probability of A and B divided by the probability of A. All right, we're going to keep that in mind. And the next thing we're going to do is we're going to write out all this information that they gave us. This problem is rich with information. They tell us that 56% of students live on campus. So that is the probability of what? We said living on campus is event B. So they tell us the probability of B is 56%, which I'm going to write as a decimal, 0.56. Remember to convert a percent to a decimal, just divide it by 100, or take the decimal place and move it to the left 2 places. They tell us that 62% of students have a campus meal plan. Well, what is meal plan? Meal plan is event A, so the probability of A is going to be a 0.62. And lastly, 42% have both. So that is the probability of A and B. Okay. So it's very important that we label these events correctly because some of this information we don't need, right? So let's go and fill in our formula. The probability of B given A will equal the probability of A and B, which we know to be 42%, 0.42, divided by the probability of A, which in our case is the 0.62. Okay, let's go to our calculator. We take a 0.42, let's clear this out, a 0.42 divided by 0.62. We get to 3 decimal places of 0.677. So a 67.7% chance that the student that we just met lives on campus, given that they have a meal plan. Okay, so I hope that makes that clear. The number one step with these types of problems, and really any probability problem, label your events. Label your events. All right, the last little bit I want to do here is you may be asked to complete a contingency table, a two-way table, and it's really just, it's not a hard exercise. I just wanted to go through it really quickly. So let's see here. So we have a contingency table. We're back to cell phone users versus whether or not they got a speeding ticket. And we're asked to complete this table, right? So all it is just like Sudoku or a little puzzle, right? So come across the cell phone user row. We know that there's a total of 145 cell phone users. 120 of them have a no violation. That means if I take 145 minus 120, we get 25. You see that? So once again, that was found by taking 145 minus the 120. That's where that came from. All right. And so the rest of these are just kind of filling in these gaps, kind of doing tricks like that, right? So then let's finish this up. Let's come down to the violation column, all right? And so there's 150 total people that had a violation, but 25 of them had a cell phone. So that means that 150 minus 25 gives us 125 individuals that did not have a cell phone that received a violation. Okay. Let's see here. Now focus on the not a cell phone user row, right? I'm sorry, I know I'm all over the place. There's 300 total people that did not use a cell phone, but 125 of them had a violation. So 300 minus 125, I believe that is 175. Okay, once again, that was found by taking 300 minus 125. Okay, so now if we focus on that no violation column, all right, we're going to take 120 plus, what's that, 175? That should give us 295. And then lastly, we just add up to get the totals, right? So 145 plus 300 or 150 plus 295, either way that you look at it, you get 445. All righty, folks, I hope this clears up the concept of conditional probabilities just a little bit, and I look forward to seeing you in the next video.